Today's project will attempt to address the issues associated with the Ford F-150 5.4 liter Triton engine. As you probably are aware, this engine, and I'm sure if you do own one, it's an issue that it's a very sensitive engine, and that the oil pressure monitoring was not very well provided for by Ford, in that they just gave the basic idiot light and that was it. We don't really have any way of checking what the oil pressure is on a day-to-day basis. So this project is going to attempt to deal with that. What this close-up is a picture looking straight up into underneath the vehicle, where you see the housing, the aluminum housing that's bolted to the engine. You see the oil filter on the back, and in the circle you see the existing oil sender. We want to leave that circuitry working as it is, but what we're going to need to do in order to deal with the problem that we have is to build our own kind of T out of brass fittings and then end up with that sender still attached and still working so that we don't have a bad indicator light. There's a parts list associated with this, and these are the basic parts: brass adapters that are 1/8 inch NPT elbow, 3-way block, some PVC line, a mechanical gauge, an inexpensive one that is, that we're going to install, and importantly the M14 by 1.5 metric adapter that has the 1/8 inch NPT nipple on the end. So here we are with the basic box of parts we're going to start with. I get most of my stuff off of eBay on the internet. I've cut the brands and names off because we're not trying to sell anything here. This is a standard oil pressure gauge. It's mechanical. I would say you spend about $24 or $5 for that, no more. You want to get the corresponding kit of things to go with it, like the PVC line and the fittings to fit the gauge. I decided to use PVC instead of copper. That was my choice on the recommendation of some write-ups that were out there on the internet that you can Google. There's another thing here, standard off-the-shelf kind of part. It's a brass T that's been machined. There's a little extra, pipe in there. All of this is the standard plumbing fixture, 1/8 NPT. If that helps you, you can actually go to probably your hardware store and find something sort of like this, but this is ready to go, and it's made to actually be used on a vehicle. There's another really high quality part in here I want to talk about, because this is the adapter that's going to be needed to actually thread into the aluminum housing. It's the M14 by 1.5 threaded metric adapter. These are all brass. It's bored out, as you can perhaps see here, with the 1/8 inch NPT, something that we need to mate with everything else that we're going to use. And then I've got an even more novel part in here I managed to find on the internet, and I want to show this to you. First of all, let me introduce the existing oil sender, which is brand new out of the box, never been used. Just got this to make sure everything matches up. So that's the M14 by 1.5 metric. You'll have to have that. But this other novel part I managed to find came ready to go pre-bored, and it's going to be useful in actually screwing in the existing oil sender I just showed you. It terminates in a 1/8 inch standard plumbing type NPT. And so we're going to build a tree of things to go under the vehicle and screw into the existing oil pan, and that way we'll be able to do the kind of multiple monitoring that we feel we need to do here. I've got some other things, a nipple, probably brass nipple threaded on each end I'm going to need, and let's see, I've got some 90-degree brass elbows. If that actually is going to end up being needed, I'm not so sure. We might have to change it around a little bit just to make sure everything fits. This brass fitting that I mentioned, that is the 1/8 inch, matches up to the existing oil sender. You want to, if you're going to use that, you'll have some difficulty perhaps finding it. I Googled for it on eBay and managed to find it, and it wasn't very expensive, but they said that it's a Bridgeport milling machine compatible fitting. So I'm going to give you a part number before I get through on that, and in case you do want to go that way. Also, if you guys are machinists out there, I just happened to pick up the required drill and tap So if you want to start off with a native piece of brass and drill it and tap it yourself to suit yourself, you certainly can do that. What I'm doing here is just I'm showing you how I get started with the project. So here we are with the pre-assembled configuration I have set up for the T that I've got. There's a fair amount of parts on here at this point, as you can see. I just want to walk through this. I always do this before I install anything, especially if it's something new. I want to start actually on this end to show you something. Actually, this nipple will be pre-installed. And it'll be at full torque, and the correct way to do that is Teflon tape the first half of it and then screw it in and make sure that it conducts electricity, because in order for this sender to work it has to conduct electricity to ground. Okay, so now we're going into aluminum. I don't have this Teflon taped yet, but I'm going to Teflon tape around here and allow this part of it to be in full contact. They've got an aluminum washer on there, and I assume there's a good reason for it. Put that in and get it tight, and then just a little bit tighter than tight, because you're going into aluminum. So I'd use basically the same torquing idea as you would with spark plugs. I don't say you need to get a torque wrench in there. Perfectionists will say yes, there's always a torque setting, but just be careful with the aluminum, and you know that you're into a housing over here that you don't want to do any damage to, and you probably won't. It should be pretty straightforward. But I believe the way that, because the space up there is going to be cramped, you're going to need to take these off to do this. This part will be installed as you see, and then you put your half of the nipple will be taped with the Teflon tape. Get this on there and then tighten it to the correct configuration. I believe it's going to be downward the way it seems. Now put a backup wrench on here before you finish tightening. Kind of time it so that everything's going to come tight with it in the right orientation, obviously. Then you can go ahead and put your existing sender on there. And I would say there again, the standard for tightening is you want it tight, but you don't want to sit here and put heavy duty pressure on it. The other fitting is a little bit more interesting in that you need the PVC line to run off of this. By the way, it is possible for you to use an electrical sender. This configuration, the way it is, you wouldn't have enough room for that, but I'm using the mechanical sender, and I mean the mechanical gauge with the PVC line, so this is going to be fine. Just one little thing to mention with the PVC line, because there are no instructions that come with it, but it's going to be necessary to cut it at a slight angle. Be sure you put the coupling on first, and then this constriction bead, it'll slide right on. If you have this cut at an angle, it should slide right on. I did a minute ago. There we go. And then before you get ready to install it, cut the PVC off square, just with any kind of clipper you got, and check it, make sure it's smooth. That should be fine. And you can run this anywhere you want. I'm going to further encase this in an automotive, slit plastic sheet that you can get at pretty much any part store, and it's not too expensive. I'll probably further at some point tape all of this, and just to keep it from corroding, or just to keep the dirt off of it. By the way, I checked into corrosion, aluminum versus brass. There is such a thing as corrosion, but the engineers out there say that it's not really a factor, and so I'm not going to spend time worrying about it. It is true anytime you have dissimilar metals that you could expect some corrosion, but frankly I don't think I'll own the truck that long, and I'm not going to spend time worrying about it. I mentioned that aluminum housing where the oil filter goes. That is a replaceable part, although I would say don't get yourself into a situation where you would ever need to replace that, because you shouldn't have to. And another question is, why are you doing this versus just take a sandwich type of connection to the oil filter? And when you look up under there, you'll find there's almost no space to work with, and it means changing the threaded member into that aluminum, and I'm just not going to take a chance with it. I don't want to do that. I want to be able to totally reverse this in the worst case scenario, but I don't think it would be necessary to. So that's basically it. Now we've got everything we need, and all we have to do is get under there and screw it in and run the line, and it should work.